section 8.4. Angles of elevation, angles of depression. So really all we're talking about today is a particular way of describing an angle. An angle of elevation is up from the horizontal. So horizontal just means like flat ground. So there's my horizontal. An angle of elevation goes up from the horizontal. That is an angle of elevation. And the dotted line is horizontal. So not a particularly complicated idea. Angle of depression. Is down from the horizontal. So if I draw my horizontal line, my dotted horizontal line here, my angle of depression goes down from the horizontal. So really it's just a particular way of describing an angle. Usually the problems that you'll have that you will get that have to do with angles of elevation, angles of depression, have to do with some application. All right, so the first thing that I want to do, I'm going to draw a picture. And for this first one, we're just going to we're going to describe the angles. We'll describe them as angles of elevation or angles of depression and what they relate to. So angle of elevation from something to something. Angle of depression from something to something. So let's take a look at that. So what we have here is an aircraft, a control tower at the airport. And here we have an airplane. So we want to describe the angle. And what it relates to. And I'm going to draw some horizontal lines here. My dotted lines are horizontal. So there's a horizontal line. There's a horizontal line out from the tower. And here is the ground. So we're going to have a person. Here's a person standing down here on the ground. I'm going to draw some angles in here. Whoops, let me make that a solid line. I want it to be solid. There we go. And I'm going to label these angles. Let's call this one, call this angle 1, this angle 2, this angle 3, and this angle 4. So we want to describe those angles and what they relate to. And the dotted lines are all the horizontals. All right, so angle 1. How would we describe angle 1? Angle of elevation or depression? Depression, it goes down from the horizontal. Angle of depression. From what to what? From the plane to the tower. So if you were given that, if you had a problem that was described that way, they would say the angle of depression from an airplane to the control tower is 27 degrees, something like that. How about number 2? Angle 2 would be an angle of elevation. Because it goes up from the horizontal. And from what to what? Tower to the plane. How about angle 3? Angle 3 is depression. It's going down from the horizontal. Oops, I wrote angle 1. Angle 3. From what to what? Tower to the ground or tower to the person, however you want to talk about it. And how about angle 4? Angle 4 is up, so it's going to be elevation. From the person to the tower, from the ground to the tower, something like that. So you'll get problems that are described using that terminology. The angle of elevation from a person on the ground to the control tower is 55 degrees. Find such and such. And we'll set up a couple of those in just a second. All right, I'm going to give you another piece of information. Horizontal lines are parallel. Horizontal is always horizontal. So if the horizontal lines are parallel, which angles have to be congruent? This line is parallel to this line. This is my transversal. Which ones are congruent? 3 and 4 have to be congruent. Those are alternate interior angles. 1 and 2 have to be congruent. Those are alternate interior angles. So when you have angles of elevation, angles of depression, you also have some congruent angles. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So the angle of elevation from the ground to the tower is the same as the angle of depression from the tower to the ground. They're just in different places. All right, questions so far? So some of your homework tonight is just labeling. You'll have a picture and it'll say describe the angles. This is what it's looking for. All right, let's look at a couple of examples, setting up problems with angles of elevation, angles of depression. The first one is you are 120 feet from a tree. So we're out in the wilderness again. So we're talking about our wilderness skills here. The angle of elevation. So in another piece of equipment that you should have when you're in the wilderness is a way to measure angles of elevation, angles of depression. Angle of elevation. From your eyes to the top of the tree is 40 degrees. And you know that your eyes are 5 feet from the ground. And we want to know how tall is a tree. Yeah, your eyes are 5 feet above the ground. All right, so let's draw a picture. Here we are standing on the ground. And we know this distance from our eyes to the ground is 5 feet. And here's our tree. and it says the angle of elevation from our eyes to the top of the tree is 40 degrees. And we know that we are 120 feet from the tree. We want to know how tall the tree is. Well, what I'm going to do is look at this triangle. So we're assuming that the tree is growing nice and straight. So from this triangle, we know that this side is 120 feet, and we can figure out this. And we know that our eyes are 5 feet above the ground, so that distance is also 5 feet. So we figure out x, we can add 5 feet, and we get the height of the tree. So I'm looking at that blue triangle, not a 30, 60, 90, not a 45, 45, 90. So we need to use SOHCAHTOA. So for this triangle, is x opposite, adjacent, or hypotenuse? That's our opposite. This side, adjacent for the 40-degree angle. So now we can go to SOHCAHTOA. What ratio tells us about opposite and adjacent? Tangent. So we say tangent of 40 degrees equals opposite over adjacent, x over 120. I can think of this as tangent 40 over 1 to remember to cross multiply. I get x equals 120 tangent 40 degrees. Plug that in my calculator just like that, and I get that x equals 100.69. Well, we know that we need to add 5 feet to get the height of the tree. So 105.69 feet. If we wanted to round to the 10th, 105.7. I would round that 6 up to 7. This would be to the 10th. If we wanted to round it to the nearest foot, we would say we would round from here. We would round that up to 106. Whoops, this should be 105.7. If we round to the nearest foot, we'd get 106.
Wait, so the tree's 106 feet tall?
Yes. It's a pretty big tree. All right, questions there? All right, let's look at one more where we have to be a little, this one we have to be a little more careful. This one is, I want to point out a common mistake. All right, we have, this time we're by the seaside. A lighthouse is 175 feet tall. The angle of depression from where we're up in the lighthouse, 175 feet up, looking down to the water, to a ship is 62 degrees. We want to know how far is the ship from the base of the lighthouse. So let's draw a picture. Lighthouses look very similar to observation towers. There's my lighthouse, or control towers. And it tells us that from where we're looking here, this is 175 feet. And the lighthouse, we're looking out at this ship. There's our ship. And we're looking from the lighthouse to the ship from 175 feet up. So we're looking there. And it says the angle of depression from the lighthouse to the ship. Is that this angle here? Angle of depression is down from the horizontal. We need a horizontal there to draw in our angle of depression. There's the horizontal. The angle of depression is this angle, not the one inside the triangle. That's where we have to be careful. So the triangle that we're looking at here is this triangle. And what we want is how far is the ship from the base of the lighthouse? We want that distance. And we know that this side is 175. So I could do this two different ways. I could extend this horizontal and I can make my triangle this way. That would work. Or I can use this little blue triangle. But be careful with the angle of depression. Angle of depression is down from the horizontal. If I use this blue triangle, I need to find an angle inside the triangle. Can I find an angle inside the triangle? Yes? What? This angle is the same as that angle. So this is also 62 degrees. I'm going to write that in blue. Couldn't I find this angle also? Now what do these two angles have to be together? 90. So this angle would be 28 degrees. So I could use either one of those two angles to set up the problem. Let's set it up with a 62 degree angle first, and then we'll show how we do it with a 28 degree angle. All right, so for the 62 degree angle, is this side the opposite, the adjacent, or the hypotenuse? That would be the adjacent for the blue 62 degree angle. This side? Opposite. So we say which ratio tells us about opposite and adjacent? Tangent. So I'm going to write for the blue angle, tangent of 62 degrees equals the opposite over the adjacent. I can think of that as a proportion. Remember to cross multiply. So I get x tangent 62 equals 175. I need to get x by itself, so I divide. X equals 175 divided by the tangent of 62. Plug that in my calculator, just like that. And I get that x equals 93.05 feet. If I round to the 10th, that would be 93.1. So that would be to the 10th. And that would be 93 feet to the nearest whole foot. So that ship is 93 feet from the base of the lighthouse. If we set up the problem with this 28 degree angle, for the 28 degree angle, is x the opposite, the adjacent, or the hypotenuse? For the 28 degree angle, is the opposite. How about this one? That would be the adjacent. So the opposite and the adjacent switch around. And for the red triangle, for the red angle, we'd say the tangent, it's opposite and adjacent again, tangent 28 equals the opposite, x over 175. We could think of that as a proportion. And I get x equals 175 tangent 28. And if you plug that in your calculator, you get the exact same answer. So it turns out the same either way. Or you could think of this triangle up here. I'll do it in a, I'll highlight it in a different color. You could use that triangle also to solve the problem, because they're the same triangle. That's 62 degrees. This is 175 feet. That's 90 degrees. So you can, and this is my distance here, x. So you can do it either way. So you have three choices on how you do this, set up this problem. All right, questions? Now, it just turned out by chance that both of the examples we did with angles of elevation, angles of depression had tangent in them. Not every single problem you do with angles of depression and elevation have tangent in them. If we had something to do with this distance along the hypotenuse, then it would be a sine or a cosine. So it was just by chance that both of these happen to be tangents. Tangents turn up more often with elevation and depression, but it's not the only ratio that you'll use. All right. Homework. There's that.